Would you please just check? Can you see the screen? Just join the team and just check, please. You know, I have good news with you. The first session is not recorded, you know. That's why I have to confirm things. Okay, good. Okay, you can see the screen as well, huh? Yeah, that's why I'm just confirmed. Now it's recording now. Okay. We have just finished this part, so I will give you one more question for your work. Let me check if I have this question in here. No. Okay. No. Okay. That question is available in the book. As I told you, means actually the this file which I uploaded in the team is just for the sake of some quick questions. Okay, it's not complete section. Please go to the ebook. We find the questions. Okay. What the message you got? No. It should be open. It should be open. Can anybody has tried to open the ebook, please? If you just try with your laptop or something else device, please try. So I will give one more question, please. Means you have to just make practice on this part as well. This is question number. I don't exactly understand. I don't remember the question number, please. Anyway, the function is like that. This is x squared minus 4x. And what's that? Add, subtract. Minus 5 plus 5. Yeah. I add. No, plus 5. X squared. Anybody has it on the book, please? Right? So let me check that. Otherwise, it's okay. Means I just want to use some practice question. X squared minus divided by 2. So it is 2. Yeah, please. Yeah, please. Okay, so go to the. Give me 42 or 43. Check, please. 42 question. What is that?
42x squared minus 4x minus 5.
Minus 5. Okay. And what is the condition here?
X greater than 2.
Greater than 2. Okay, that's it. Okay, that's it. Good. So this is 42, please. Please, right here. 42. So the book is working. My friend name is opening. Just try, please, one more time, or you can take help from IT as well, please. Now, please, we need same thing. We need inverse function derivatives. Come on, I have done this question for you before break. Now, please, it's your turn. Try. Yeah, please.
We need to do the b over 2.
Of course, because if you try, if you swap x to y, y to x right now, you are not able to get inverse. That's why here we need which method? Completing square. Yes. Please, come on. Then we start the last topic from sir.
It should be in the form x minus h squared.
Yes, of course. Completing square method will give this form. It's called vertex. Then you will be able to get the inverse. Yeah, the number which we have to add. So the first condition is correct.
It should be
Because A is positive 1. Okay, good. Now find that number which you have to add.
4.
What is 4? You're right. Good. Because it is b divided by 2 and square. It is 4. Yes.
So we add 4 then minus 1.
And no, add 4 and subtract 4. The same number you have to subtract and add, please. Okay.
So it will be x squared minus 4x minus 5 Plus 4 minus 4.
Yes, exactly. Minus 5 and minus 4. You should know where you have to add and you should know where you have to subtract. We always subtract in the last basically. And we add in the after second place. The third place is that number which you have to add. So yes, you're right, means the number which we'll have to add b divided by 2 and square. It is minus 4 divided by 2 and square, and you're right, it is 4. Exactly. So the number which we have to add, it is 4.
So minus 1 minus 4.
So this is x square minus 4x. Please, you should know this thing. The exact place of add. We always add that number at the third part. Okay, so the third location you have to add. Then we have subtract same number. We always subtract in the last. I add the number 4 and I subtract the number.
So it should be minus 1 minus 4.
It's minus 5 minus 4. Yeah.
Why you added in the middle? Why you?
Yeah, actually the addition is the number which you found to add is always third place. Is a rule, exactly. Is a rule.
Perfecto. The last 4 would be x squared minus 4x minus 1 minus 4.
Okay, now look at here. As I told you, when you add the number correctly, the first 3 terms is always a complete square. Now just use your algebra skill and tell me this becomes how, you know, the shape of the square. It becomes, okay, it is negative sign, so it is a minus b. So it is x minus what? 2. Always the last part make it square. So 4 is square what? 2. So these 3 terms will be x, because here is minus in second term, so minus. 4 will be right as 2, and this is the complete square. I hope you understand.
Okay, so the square,
At least.
it should be in this order always. Like I can't write plus 4, minus 4, and then minus 5 at the end.
No problem, no problem. You can write. No problem. She's asking if I add here minus 4 and then minus 5. No problem. It's just your understanding, please. It's fine.
What about the minus 5?
Now, minus 5, minus 4, how much? Minus 9, of course. Because only these 3 terms become complete square. The rest as it is.
Minus 2, we just get the square root of 4. Like the square root of 4 is knowing the square root of 8.
Yeah, 4 means what? The last term here, okay, it is 4. So 4 is the, what 4 is the square of what? 2. That's why.
Ah, so it's always going to make it the.
Exactly. Let's check that the number which you have here, how I write is square.
Okay.
Let's say the number is, for example, 8. How you write in square?
2.
Radical. We can write in radical.
You can write that.
Yeah, it's okay, it's no problem. Right now, because of the, you know, in the initial understanding, they put that question where this number are in the complete square. That's why. Otherwise, this number can be anything. So, for example, here, you have 8. How I write 8 as a square? So, here I write square root of 8. It's not the square of anything, please, okay? So, you write 8 as a radical sign, radical 8.
So the final answer is y equals 2 minus the root of x plus 9?
Plus minus.
9.
Okay, just wait, let me make the correction here.
That's if it was 9, 3.
3, of course, yes. If it is 9, it becomes 3, 14.
How do you put radical inside to set that?
Because some numbers are not complete.
Yeah.
So the number not complete, you have to write in radical sign. Because, look at here, for example, how I write 5 as a square. Means if I make square, I need 5. So I will write this one, because if I solve it, I get 5. Okay? Yeah, because here we need square. So you should know how to write a number in square basically.
So inside we write only the radical.
Yes, you write only radical inside. So exactly. Okay? Don't worry, these things will come up, don't worry.
But doctor, I have a question.
Yes, please, go ahead. Yeah, one by one. Yes, please.
Like it would be wrong if we put the -5 instead the +4.
If we write -5 here.
Yes, and the third place, as you said.
Actually, the procedure says the first three terms is a complete square. So if you put -5 here, it's not become complete square.
First three.
Yeah, first three terms always complete square. Either a minus b or a plus b. It depends on the sign of the center part. Yes, please, my friend, you have some question.
How you make that one to
How this one like that?
Yeah.
Okay. Actually, if you look at here, the complete square forms means I already introduced you. For example, here I have a minus b square, which is basically a square minus 2ab and plus b square. So you can see here that my first term and the last term basically they are the squares. So you can see here I have square here, my first term. The last term I can write as what? 2 square. So this middle term is this one, means 2ab. Now just use some algebra knowledge and try to write means this in that form. So if I because here is square, so I can make like that. So if you expand, if you open it with this rule, by the way, you can cross check, you can verify that I have made this correct or not correct. You can check. Look at here, please. Look at here. Please, this one, x minus 2 power 2, please expand by this rule.
X square.
A square means x square minus 2 times a. My a is x. B, my b is 2. Understand? Then plus b square means 2 square. Now check the answer, please. It's x square, huh? 2 times 2 is minus 4x. And 2 times 2, please check. Is it same like this one?
Yes.
Yeah.
So you can cross check. You can verify that the form which I made as a complete form it is correct or not correct. So you can check this. Now I hope you understand. Okay, good. So right now means so this is basically vertex form. Now you can try. Now you can try its inverse. Now swap x to y, y to x, and please proceed. So you know the condition, the question is the condition. X is greater than 2. Keep this in your mind and go ahead, please. So now you can swap. This is x now because it affected y. It's y changed to x and x changed to y. And now you can perform the thing, please. So you have to apply again positive, negative square root. Okay. So when you reach one stage, you have two options, positive or negative. So you can see the y is greater than 2. So you add into or you subtract into? Add. So you get 2 plus square root.
It's bigger.
It is bigger, yes.
The final answer is 2 plus.
Okay, so what is the final answer, please?
2 plus root x.
2 plus root of, yes?
X minus plus 9.
X minus 2.
Plus 9.
That's nice.
Plus 9.
X plus 9. 2 plus x plus 9. This one?
Yes.
Yes.
Okay, so this is your inverse. Very nice. Now just differentiate, take derivative.
1 over 2.
So 2 is constant, that is 0. So now we have the f inverse prime. The derivative of the inverse is 1 over 2 times, and this is x plus 9 times 1. No need to write this answer of this 43 or 40%. 40%.
And the
Okay, the idea, please.
Yeah, and the 2 is 0 because it's.
Yeah, it's a constant. The constant derivative is 0. Please. This one? Actually, I just write the answer from some boys told me. If you solve it, you get 2. Let's continue. Means this one you shift other side.
Okay,
Is that right? Okay. Right. Sorry, there's a question, please.
No.
Is it okay? Yeah, okay, I'll solve it for you, please. So from here, please, I can. So move this minus 9 this side, please. Becomes x plus 9 is equal to y minus 2 square. You have to cancel squares. We need square root both sides, please. Positive, negative square we apply both sides because the square is cancelled out.
Yes.
So you have now x plus 9 with positive next square root is equal to y minus 2. Okay. Now this minus 2 you can shift other side, please.
Yes, so the way. Yeah.
So when you shift this minus to other side, it become positive. Am I right, please?
Yes.
This minus 2, move other side, it become positive 2, okay? Then we have here positive and negative square root of x plus 9 is equal to y, and definitely still now is not function. Function need only one output. Right now you have two outputs. You have to answer y, which is violation of function. So either it is positive or it is negative. It depends now on the domain condition. So if you go back to the question, please. This say x greater than 2.
Y.
In inverse, it becomes y greater than 2. So basically, this is basically y. Sorry, this is basically y greater than 2. This is y greater than 2. So we need y answer more than 2. So what should we do here? We add in 2 or we subtract in 2? We have to add. Then we get the answer more than 2. Please.
If it wasn't written, but x is.
It's not the question. It's the wrong question. Of course, square function is not one-to-one. How you find inverse? Square function they make one-to-one by controlling domain. Otherwise, it's not one-to-one. There is no inverse possible. Clear? So whenever you have a function who is not one-to-one by nature, you always get a condition with that. Otherwise, the question is not correct. It's wrong question. Please.
Like doctor, you explained before, graphic-wise, like the x squared, it was like a parabola. And
Yes, exactly. They have to make some condition. Otherwise, it will not become one. Yeah, exactly. Okay, so definitely with the condition we have to add in 2, okay? That's why we get the answer more than 2 of y. And this is inverse. Now get the, how we get 2 now? Is okay?
Yeah.
That's it. Now please find the derivative, you get the answer. 1 over 2 times x plus 9 square. Clear?
Yes.
This is the first topic, please. Now in second topic, okay, how is the question please? What is the second topic? Actually, the difference between this topic and second topic is that in second topic we need same thing. We need the derivative of the inverse. However, in second topic you have one additional information. Actually, now you need inverse at some point. A point will be given to you. A point will be given to you. Means find the inverse function derivative at this point. Okay, so a point will be given to you. This is the only difference here and the topic which we are studying. Okay, and this, point concept, basically from this point concept we will get a formula, we get a property. This property we can check now, please. I will show you the question first of all. So look at it, please. This is from 35 to 30. Again, I'm sorry, means actually. Can you confirm, young lady, please? You have book. Fatma, your name, please? Sharma, please. You have this, just check. These are correct because you have a new edition now. So 35, 38 are same question, please? Just take a confirmation, please.
Yes.
Because I copied from the 14 edition, now it's 15 edition, so.
No, it's not the 15. It's the 14.
It's 14?
Yeah, I'm not opening that.
You're opening from your old course?
Yeah.
Oh my God, okay. Anyway, so if you open from the new course, so it's a 15 edition. Okay, anyway, so in 14 is same. Anyway, look at the question, please. Look at it. Inverse, we have done this topic, okay?
Doctor, this is a
Graphing, no need, please, by the way. We are more interested in part C. Look at the part C. They said, find the function derivative at which point? A is given. Look at A here, how much? -1. Here A how much? Half. Here A half. And here A 5. So it means we are basically answering part C, okay? Part A we have done already, and if we need here, which one we do, don't worry. Okay. So what we do? First we take the derivative of the function. The given question we take its derivative, okay? At which point? A. At the given point. We take the derivative. When we get the answer, we put the point, okay? Good. What is next calculation?
Derivative.
We need inverse function derivative at which point? Oh, not A. F of A. Try to understand the question, please. Function derivative at point A, inverse function derivative at F of A. How you get F of A? What does it mean by F of A? Means this is function. Substitute here A value, you get F of A. So inverse derivative you calculate on F of A, okay?
Yes.
Now, okay, when you perform these two calculations, basically there is a property. You will get a rule, and look at the rule. You check the inverse function derivative which you calculate at F of A is basically it is equal to the reciprocal of the function derivative at which point? At A. So they are equal. Again, please, there are two different calculations. Please try to understand. Number one, we calculate the given question derivative at which point? A. Then we calculate the inverse. Inverse derivative we calculate at F of A.
Yes.
Then you check the, a property. The property says, when you perform these two calculations, you will observe the inverse function derivative is basically equal to the reciprocal of the function derivative. But again, you should know, you calculate function derivative at which point? Function derivative, which point you calculate? Function derivative at A. Okay, I will write for you the rule, means you can. The rule is that. The rule says, please, the inverse function derivative at F of A is basically equal the reciprocal of the derivative function at which point? At A, yes, okay. I can write this one only A is fine. At A. This is the basically property.
And that's the rule.
This is a rule. This is a property, a rule basically. So first, actually, he just want to show you how this rule is basically working. And then inshallah we use this rule to save time. Means, for example, I just give you the basically only point A. In exam, you get the question. Means we only give the point A, and we ask you find the derivative of the inverse function. So what we do not calculate inverse because we know very well the inverse function derivative at F of A is basically just a reciprocal of the function derivative. Just calculate the function derivative, put its A value, and flip it. That's it. You get the inverse function derivative.
We don't need to flip.
Without calculating the inverse. This is the benefit if you have point. Okay, so let's do a question with this guideline. We check the property, then we apply the property. Okay, directly, please. Yes.
This is 7.2.
It's 7.111. The second topic. I told you the two topics. One topic we finished without any point. In second topic we have point now.
Wasn't there a rule you said?
Actually, the rule is here. This is a rule, by the way. This is a rule. Look at here. This is a property. First of all, we check this property. And then next I will take a question where we apply this property. Okay? So just wait. Let's follow the guideline. So let's start the question. For example, we can go for the question number 36, please. The sake of understanding. Let's copy 36 question. X plus 2 over 1 minus x. 36 please. Question number 36. Function is given to us x plus 2 over 1 minus x,
Yes.
and a is half. And here we have a value. A is half. Okay. Now, as per the question, please, part C. Look at here, part C. First calculation is that find function derivative at which point? A. Okay. So please go ahead.
So we derive.
First of all,
and then
yes, this is my function. I will calculate its derivative. Come on. F prime. Which rule? Quotient. So I have 1 times 1 minus x minus I have x plus 2. Then what is 1 minus x derivative? Minus 1. Ah, very good. Be careful. Huh? Minus. Good. And divide by 1 minus x squared. Okay. I will simplify first, please. So I get 1 minus x. This minus and that might become positive. I get x plus 2, please.
1 minus x.
And divide by 1 minus x squared. So this is cancelled out. So my derivative of the function f prime will be 3 over 1 minus x squared. Do you understand the derivative of the function?
Yes.
As per the question, I need my derivative at point A. X is equal to A. How much A given? Substitute. Substitute.
So we substitute.
Please substitute here x value A. A is how much? Half. Please substitute x value half. Now look at it, please. What I'm doing now? Look at it. As per the question, the derivative of the function is at x is equal to A, and A is half.
20.
So substitute here 1 minus half and square. What answer? 12. Yes, I did not do anything. As per the question, I calculate that function derivative. I substitute x value half. I get the answer 12. Please, yes.
We get the reciprocal 1 over 12 is the inverse, right?
Just wait. We have to confirm first of all this property. Then I will take a question where we apply this property. Okay? Right. So please, this is the first part of the question. Look at here. Find function derivative at A. Done? Answer how much? 12. Clear? Okay. Second calculation. Read here. Now you need inverse. What do you need? Inverse function. Calculate its derivative on which point? F of A. First of all, we need inverse. Then I take derivative. Okay? Actually, you will observe that how much, when we use this property, we save how much time. We save how much time. You will observe, please. Now look at here. First, I need inverse. Because as per the question, I need derivative of what? Inverse. So look at here now. First, I will go for inverse of the function, please. This is my function. X plus 2 over 1 minus x. First, I need its inverse. Come on, please. Swap x to y, y to x, and get inverse, please.
So not the inverse of 12, it's the inverse of the function.
Yeah, as per the question. Now, the second calculation is that we need the inverse function derivative. So first I need inverse. So for inverse, I swap please x to y, y to x. So for inverse, please, I have x is equal to, what's the question?
Y plus 2.
Y plus 2 over 1 minus y. Am I right? Please swap now. Please solve for y so that we can get inverse, please. Cross multiplication.
Y plus 2.
X minus xy is equal to y plus 2. I need only y values. This 2 I should decide. So x will go with minus 2, and here I should decide y plus xy. So here I can take y as common factor. I get 1 plus x. And for the inverse purpose, I divide both sides by 1 plus x. So y is equal to x minus 2 divided by 1 plus x. Can I write 1 plus x as x plus 1?
Yes.
Any problem? No. This is my inverse. Do you understand or no?
Yes.
Simply what we did before, we just find the inverse. Okay? Now, as per the question, please, we need inverse function derivative, okay? Now calculate derivative, please. Derivative of x minus 2 divided by x plus 1. X plus 1. Okay, so for the purpose of derivative of inverse, this is 1 times x plus 1 minus x minus 2 times 1 and divide by x plus 1. Simplify this. So this is x plus 1 minus x minus 2. I think I get minus 1, right?
That's supposed to be x plus 1 squared, right?
Yes, in the denominator. So I get minus 1 by x plus 1 squared. Am I right or no? No?
X plus 2.
X plus 2?
Not negative.
X plus 1 minus x minus 2. Ah, this one. Oh, yes, because I have negative sign outside. You're right. So it is 3. Yes or no?
Yes.
So please, this is my inverse function derivative. All of you understand this?
We can go up just.
Okay.
So why is it x plus 2?
Please. We swap and then we calculate here inverse, then we derive. Because look at here, actually this is the formula here. It is u v prime. So u is x minus 2, please. So take bracket. Then 1. So when you open the bracket, it becomes positive. Positive. I think you understand now. When you open the bracket, it becomes positive. So 2 plus 1 is 3. Now it's okay?
What about the next step?
Okay. More up, look at here, is it okay?
No.
I move this plus 2 on the side become negative. I move this minus xy, this side becomes positive. Because we need y. That's why. So, is clear now? Okay. Yes, please.
Down here, what about the x?
What about that? Okay, actually, this x and cancel out. I'm sorry, actually, I skipped one step. I should go for that. That's why we have some here. Okay, so look at it, please. X plus 1, then minus x plus 1, and divide by x plus 1 square. So you can see this is cancelled out. So you have now 3 divided by 1 plus x or x plus 1 square.
And what about the one there? The
2 plus 1 is 3.
No, there.
Is multiplied. Look, so 1 time x plus 1 is x plus 2. Look at multiplication. Okay? So I get the inverse function derivative. Now, please, as per the question, you need the inverse function derivative at which point? F of A.
Well,
Now, please check what is f of A. F of A means, this is my question, substitute here a half, so then you get f of A. So how much f of A?
Substitute in the question or in the my final
F is a function, question, please. Sorry. So now we need basically f of A value, please, so that we can get the derivative at f of A. So for f of A means f of half. So your function is basically function question. Your question is here. The question x plus 2 over 1 minus x. X plus 2 means x plus 2 over 1 minus half. So how much please? Sorry, 5? 5. So basically, means our f of A is 5. Now we need this inverse function derivative at which point? 5. So please substitute 5, please. Please substitute 5 now. So this is one calculation which we need. We have done. This is f of A. So f of A is basically 5. So kindly calculate the inverse function derivative at 5. Give me the answer, please. How much? 1 over 12. Okay. Now we check the property. The function derivative at A, how much? Look at here.
12.
The function derivative at a, how much? 12. Okay? Look at the property. They said the inverse function derivative is basically the reciprocal of the function derivative. So the answer of the inverse function derivative is 1 by 12. So look at it, please. So now we have to verify. Look at here. Okay, I write the property. The property says, please, the inverse function derivative is basically reciprocal of the function derivative. Okay, please, it is understood. This is at f of a, and this is at, a. Yes. What's the answer to this one? What is the answer to this one? How much? 1 over 12. Look at it. This is 1 over 12. It should be, must be equal 1 divided by, what is the function derivative you calculate? How much? So check, understand? So property verified. Yes, this property works. So we just verify the property. Right now we just check the property that it is working or not. It's working.
But it's not
It is true.
Doctor, if it's not equal, it's wrong, right?
So maybe you have some mistake in your calculation. This property is basically verified property. It works. 100% works. Now, how we use in exam, okay? How we use this property in exam, okay? So I will write a question for you, and then I will guide you how you can use this property, please. Okay? Anyway, you understand how this works?
Yes.
But again, I'm repeating, please. The inverse function is on which point? F of a. And the function derivative at a. You should be very clear in mind, please. Inverse function derivative, we calculate f of a. Function derivative calculate at a. Then this property works. Clear? Okay. Now I give a question, means how in exam you get the question, please. Right. So let me. Actually, for frankly speaking, because until now we have not started the transcendental function. We did not discuss right now log function, exponential function, okay? That's why in 7.1, if you look at the questions, all are algebraic functions. But please, in exam, we can put any question for you, any function. I can put, for example, y is equal to ln x over 3, for example. I can put y is equal to 3e power x divided by 2, okay? So any function I can put in exam, okay, for this topic, please, okay? Because we know how to differentiate log function, we know, which I will learn in the next topic, please, right? So don't expect that you only get this 2x square or 5 minus 4x as a function. No, we can give any function to you in this topic. Clear? You are not finding any function of log transcendental function because we have not started yet. We start at 7.2. The first function which we discussed, which is log function, we start in 7.2. That's why, okay? Right. Anyway, means for the sake of understanding, I can use from here any question, please.
Doctor, can you solve one length one?
Actually, the function, the question should be valid. Means I don't know the function. I will put maybe it is not 1-to-1. Then how you find the inverse? Okay. The function you know very well. I told you for inverse calculation, the function must be 1-to-1. If I put any dummy function, quite possible the question not valid is wrong. Okay. As one person said, if there is no condition less than greater than what, so it's a wrong question. Okay. But anyway, means for the just for understanding, we can take any. Let's say we can take 37. 5 minus 4x. Yeah, please, sorry.
So we're doing this just to check.
These calculations we just perform to check the property. Right now, it's confirmed. This property works. I showed. Look at this. Property work, okay? Now, how you use this property now in exam, let me show the way, okay? Look at it. So, in exam, you get the question, please, like that. Let's say I take this 37, this 5 minus 4x, and a is again half. Okay, please look at it. So I'm just take a question, please, for exam point of view. F of x is equal to
5 minus 4x.
5 minus 4x. 5 minus 4x.
Is-
And A, how much, please?
Half.
Okay, good. Okay. Now look at it, please. Find the inverse function derivative.
We first derive and
Now look at here. Means I just give a question exam point of view, how you get the question exam from this topic, please. I have given a function to you, okay? And I give the point, okay? What's the requirement? We need inverse function derivative. Now, please, use the property, please. No need to find inverse, no need. Don't waste time. Because we have point. We know very well that the inverse function derivative at f of a is basically simply equal the reciprocal of the function derivative at a. So what do you do, please? Just take the derivative of the function, please. F prime. What's the answer? Negative 4. Substitute a. So there is no x. So basically, the derivative, okay, means the function derivative at x is equal to a, which is basically half, is how much? Negative 4. Our requirement is not the function derivative. What's the question? We need inverse function derivative. What do you do?
1 over.
Just flip the answer, that's it. Means now the derivative of the inverse function is basically simple reciprocal of the function derivative. So without any calculation of inverse, you get the answer.
But doctor, this is at 8, at A,
And then, yeah.
stuff in the exam, can we just write this?
Of course, that's why I'm telling you how you use the property. So no need to calculate inverse. Sometimes you get the function whose inverse is very complicated or sometimes not possible. Then we use this property because right now it's a dummy question, very simple question, please. So in exam, you get, for example, cubic function. Yes, please, can you give me one more question from the book? Who has cubic? Maybe 41? Check, please. 41 is cubic. Go ahead.
Yes.
Am I right? Okay. Question over here. Okay. So, yeah, I will give example, please. So look at here. Question number 41. Give me the function, please. Is what x cube?
X cubed minus 3x squared minus 1.
Minus 1. How much a, please?
X greater than equal to 2.
Okay, sorry. Means first he give the condition. So he says x is greater than
2.
2. And what is a?
2 equal.
Okay, and a?
It's written here as the point x equal negative 1,
Oh, okay. X is equal to negative 1.
and then it equals to f of 3.
F of?
3.
Okay. Okay. I think it's good. I discussed this question with you. Look at the 41 question, please. Okay. For the requirement, what we need? Find what? Find what? Find what? Derivative of the inverse function. Okay. Good. Yes, I think it's the best question to understand this, property. Why? Number one, the problem is that, look at here, you cannot find one of this question. It's very complicated. And what's the question? We need the derivative of what? Inverse. And inverse you cannot find. It's so much complicated. Then how we, get this answer with a solution? So solution is that we use now this property. Without means, for example, here as I told you, means calculation of inverse is very complicated. No need for inverse finding because we have point. The point is given here. Now this is one more, understanding. What is A here? This is a big question. The information which is given in this format, please tell me what is A value?
3.
Sure?
Yes.
Minus 1 is A or 3 is A?
3.
3 is there.
Because it's A
F
of
of
A.
Ah, very good.
Only A is
Exactly. It is 3, all right. Because it is F of
A.
F of A. Nice. So, yeah, basically, in exam, you get the question, please, think like that. So, as I told you, you cannot go in a normal way. What's a normal way? Please, first you find inverse, then you find derivative. It's not possible. Why? Because inverse calculation is complicated, very, very complicated. You cannot find inverse. So, okay, because we have point, we no need to find inverse. What we do? We find the derivative of the function. We put the value of A, and then what we do? Reciprocal. That's it. You get it.
Take the 3, Doctor.
And A is 3 there. Do you understand now how we can use this property, please? Yes.
What about the condition? X greater or equal.
Why is it here?
So,
Because not one-to-one by nature. They put this condition to make it one-to-one. Please.
so it's not gonna like.
Yeah, I told you it's already one-to-one, so don't worry about that. So just go for the normal calculation of the inverse, okay? So as I told you, in this case, no need to find inverse. No need. And even you try, you cannot find inverse. It's very complicated function. Clear? Okay, so what we can do here, we can use that property which we learned, please. What is that property, please? The property says, please find the derivative of your given question, given function, please find its derivative. Simple way, please. Whose derivative? 3x square minus 6x. Do you understand what we are doing?
Yes.
We are using the property, please. Means we need, the question is that find the inverse function derivative. Unfortunately, we cannot find inverse because it's very complicated, okay? Because we have points, so we can use the shortcut. Shortcut we can use proper. What property says? Find the function derivative, understand? But this function derivative should be at which point? A. Go to the information. Check. What is A? 3. Please, it is 3. A is 3. My friends, A is 3. Please. This is A value. This is A. This is A. Please, this is A value. You know, what is that? The what? This is F of A. And you can check it. Put in the question 3. This is, minus 1 is F of A. Substitute 3 in the question, you get minus 1. Yes or no?
Yes.
So, where is A? Where A, how much? 3. So, calculate the function derivative at A, and A is how much? 3. So, please substitute now 3 here.
You get negative.
So, means derivative of the function at x is equal to 3. Yes, tell me the answer.
7.
Sorry? 9. Okay. Now, the property says the inverse function derivative is basically is the reciprocal. So, because it's a question. So, the inverse function derivative, is basically 1 by 9. And that's it. Do you calculate any inverse here? No need for that. Use the property, please. That's why we learned that property first. Please.
How do you know if you do this or if you solve in the first question that we solved?
Uh,
How do you know?
Actually, it's your choice. Means if you are comfortable, first you find inverse, then find its derivative. It's up to you. But I told you, you start finding inverse, you will stuck, of course. You can find inverse.
You have to do division by.
A lot of things you have to
So
do.
in all questions we can use this method.
Actually, do one thing. You have a good question. She's asking which question I will do this one. When you have point, do this. Without point, you cannot use this property.
So you should use the first one.
Exactly. If there's no point, then the way which we did before, the topic number 1, we can do it that way, yes.
Point like A.
Exactly. And this point, maybe now, actually, I think it's a good thing that we discuss this question. See, here, see, here they have not given you A directly, no. Yes or no? Here, in this question, A is given. How much? Half. easily given, but here you have to identify trick. Is that right? Mostly, no, it depends. Means the question we put in that form or we put in that form. You should know the concept. That's it.
Let's start a question without A.
Without A, the question becomes same like before, please. If there is no point, so just find the inverse first and then you can drive. Because there is no point. The point is here, you can avoid inverse calculation. Use the property. Find the function derivative, use A point and flip it.
Substitute and
Get
But
it.
most probably in the exam, it will be with A or without A.
Maybe two questions we can get. One question from that one question from that one. Quite possible. Yes, please.
The question now, that what's the benefit of -1?
Nothing.
Nothing?
Actually, basically, the rule says, as per the property, the inverse function derivative at -1 is basically equal the reciprocal of the function at 3. Means the property says, means if I just explain this -1, basically it says the inverse function derivative at -1, because it's f of a basically, is equal the reciprocal of the function derivative at which point, please? This is the meaning of this minus. Okay, because the property says the inverse function derivative at f of a means if I explain in general form, this is basically the inverse function derivative at f of a is basically equal to what? The reciprocal of the function at which point? A. I hope you get the idea. Nice, okay? Good. That's it. This is 7.1, please. Yes. So we discussed two topics, please. Means in first topic we first find the inverse and then differentiate. Second topic we basically have points, so we avoided the inverse calculation. We skip it and we get directly the inverse function derivative. Clear? Good. And then one more thing here, please. If you have square functions with the given condition, so you have to use completing square method. Clear? Because without that, you cannot find inverse. Right?
Even in this one? Even in this
Yeah.
second topic.
Second topic, please. No need for inverse. My friend, have you find inverse here? No need. If you have point, avoid it, please. Because mostly, they in this topic, mostly they give you a question which is very complicated to find inverse. So you cannot find inverse. So don't try, please. Even don't try.
There's point.
You have point, use shortcut, please.
Okay, let's try another question without A, just to.
Without A, we have done many questions. Look at here. These questions means here. These questions are all without A.
This for the topic 1?
Topic 1, yeah. No point. So what we did? First we find inverse and then we differentiate. Here when you have point, no need to find inverse. Directly means find the function derivative at A and in the last flip it. That's it. Clear enough? And oh yes. Here you have A directly, but we have two questions, I think 41 and 42, where they have given A in this form. So you should know who is A. Sometimes you put A -1, which is wrong. A is not -1, A is 3.
Yes.
Clear now? Good. Any more questions about this topic, please? Is clear? Okay, anyway, as I told you, open the e-book and please try to practice more and more. The study plan, basically. For example, I hope you know how to use study plan. I will again repeat, please. Now, when you open study plan, go to the section 7.1 and only select those questions which are the part of our topic. For example, you can select question from 25 to 34 in study plan. Select question 25 to 34, then, 25 until 38. Then we have three more questions, 41, 42. So please only select in study plan those questions which are related to a topic, please. There are a lot of questions in the 7.1. If you click one by one, they are not related to the topic, please. So in study plan, just in the book, just check which questions are belong to our topic. For example, I told you, our topic is from 25 until 43 questions. So when you open the study plan, only select the question from 25 to 43, please. And so when you click on these questions, you only get the question related to this one. And just practice, please. Okay?
Well, Doctor, you said the questions are different, the numbers, sorry.
No problem. It depends. I think if someone open the ebook, so we can verify how much they're different. I don't think so. There's
This one is 41 to 44.
See, you have tech. See means so please, if you open the ebook, you can see the topic question. Please means numbers. Because a new edition, actually, you will be surprised that in new edition they do not add any new question. They only the numbers. That's it.
They're the same.
Same question. Yeah. Always they do like that, please. Means if you have new edition, at least add some new questions, some more. No, only change the number. That's it. This is a new edition. Anyway, so let's go for the 7.2, please. I was expecting to finish today 7.2. Anyway, is one portion of derivative we can finish from 7.2. Okay. So 7.2, please. Which is called logarithmic function, but please in 7.2, I told you already, log functions are two types. Base E, base E?
Yeah.
Actually, base E means natural log. And base A, which is common log. But most particularly, we are interested in basically natural logarithms. Natural logarithms. Why? Because we need their differentiation and integration. Only natural logs have differentiation and integration. Common log means ordinary log, they don't have. Means log, you cannot differentiate. You cannot integrate. No. But we have questions to integrate. So how? We learn inshallah. Okay. Now, first of all, as I write here, natural logarithms. Basically, any log function. Please, I think it's better before I go to particularly natural log. First, we discuss the structure of the basic log function. Every log function, please, every log function has basically two parts, two components. Every log function has two mandatory components, compulsory components. Without these components, it's not complete. So, this A and this X. This A is basically represent what? Base. It's a base, yeah, it's base, very good. Base. And this part is called what? This is base, okay.
Constant.
Huh? What do you say this part? That, of course, this X is variable, but it has a name. No, please. So, please, note down. Every log function has two components. Base and argument. What do you say? Argument. Every log function. It is natural log or it is common log. Please, every function log has two components, base and argument. Without that, it's not complete, please. Clear? So, for example, y is equal to log x plus 1, for example, log x plus 1. If I ask you, what is the argument here? Very good. Base. There's no base, please.
But it should be said.
Yeah, good. If there is no base mentioned, It is 10. By default, if there is no base mentioned, and please, we have some question like that. Means they give you some log function without any base, and you have to integrate. So when you integrate, so please, it is understood base how much? 10. Unless until they will put some other base. So if no base mentioned here, you're right. So base is 10 exactly. So base is 10, and argument is basically x plus. Good. Anyway. Okay. Good understanding. Let me now I write basically natural log stuff. Okay. How much argument here?
One.
Argument, please. Argument.
X,
Argument is x. Base.
E,
How much base?
E,
Base is e. Please. This is the way you have to understood. Please. ln(x) in natural log, it is confirmed its base is e, the special number, the special constant, 2.1718, and continue, please. It's an irrational number, is a non-terminating number. Means after decimal, it is throughout continue, please. So please, if you make the component, this natural log base is always how much? E. Natural log is that log whose base is e. And you can find, if you have calculated, you can still find the e value 2.17 and continue. And of course, this argument means this is argument basically. This argument is x. Argument is x. Do you understand the structure of ln(x), please? Okay. One last function I write here, and then we go for some more property. Okay. How much argument here? Argument how much? X. Good. Base? Base 3, yes. Is it natural log? Is it natural log? No. Natural log always write ln. If you look at your calculator, you have two different options, ln and log. ln and log, yeah?
Yeah.
So because they have a division, means ln is natural log, log are common log. They are two different things, please. That's why even on the calculator you have two different, options. Okay, good. Let's start with, okay. Before I start the, questions related to differentiation of log functions, means natural log. I told you, you cannot differentiate directly common log. Okay, LOGs we cannot differentiate and integrate directly. It has some other way. Okay. So first we learn how to differentiate natural log. Okay. But before I start the differentiation, this very important thing which we have to learn. There are some properties of log. You have idea properties of log functions? Okay, so I will list down some properties because without that properties, the log questions become very, very complicated, very, very difficult. If you use these properties, the question become very simple. So what we do not, sometimes the question was very lengthy, very complicated. So what we do, first we use the properties, the question becomes very simple, and then we take differentiation. Okay? So I will list down now. Number one, please. Now I'm just giving you the properties of log function. I'm not saying natural or log. This work for all the log function, even natural, even common, please. Okay, so please look at it. Number one. Please. How much the argument here?
X.
X. It has power?
Yes.
How much power is there?
And
This power is on the function or on the argument?
the argument.
Please, if the power is on the argument, please, then we apply the property. Because sometimes power comes on the function. Don't apply this property then. If the argument has power, so basically we can write n log x. You know what happened to the power? Power is break down.
If it wasn't a power,
So if the argument has power, so this power we can bring down. We can write before log function. For example, please, I have log x power 3.
3 log s.
Oh yeah, so we can write this one 3
Log s.
log x. Okay, I will give you one more example. Okay, so how can I now? 10?
No,
No?
we can't because the 10 is the,
For
like,
the
for the
entire-
course for the function.
Please, yes. This time, the power is not an argument, please. This is a function power. Log function has power. So don't use this property, no, please. Do you understand the difference?
Yes.
If power is on the argument, please, then you can apply this property. If power is on the function, don't apply this property, it's not valid then. The power of the function, okay, I'll give one more example. Then I ask you, can I apply now this property, please?
No.
Who has power? Function or the argument?
Function.
Function has power. Argument is here, this is argument. Oh yes, if I have this one, then you can say it becomes, before the law. Okay? So please, be careful, please, be careful. Means this property only works if the argument has power. So is clear, first property?
Yes.
Very good. Second property, please, number 2. What you can say, okay, how is the argument?
No.
What's the argument here? Argument, please.
X, Y.
X, Y. What is the binary operation between them? Multiplication. If the argument has multiplication, so we can expand with addition. Do you understand what I did here?
Yes.
The product of the argument becomes addition, please. We can expand with addition. Clear?
If it's divided, minus.
Very good. If it's divide, we can make it minus, subtract. Okay, for example, I have this example. Okay, how can I write log 3x? The argument has product, 3 and x has product. So you can break it.
Yes.
You can say log 3 plus
Log s.
log x. Very good. I hope you understand the property.
Yeah.
Number 3, you already discussed that if the argument has quotient and division, like that. So what we can do?
Log 2x minus.
Now we expand with subtraction. Yes, it's very good. We can now subtract. For example, sometimes, let's say, for example, please, I have log x by 3, for example.
Log x minus log 3.
So I can write log x minus
Log 3.
log 3. Understand? Basically, we only need mostly frequently these three properties, mostly. But there are 2 more which I think we should discuss because sometimes we also need that one. Actually, that properties you can also find with the calculator, but it's better if you discuss. So no need to use a calculator, please. So I think you can also add these 2 more, please. For example, log 1. You know what is log 1? 0. Log 1 is 0. Exactly. Again, it is also for ln. Please, ln, log same properties, log 1 or ln 1 same thing. ln 1 0. Okay? One more, please. Here I have to use, okay, particularly ln. Why? Because ln and e are basically reciprocal, huh? So ln is how much?
1.
1, please. Because I cannot say loge, okay? Because loge is not natural. Natural log inverse is e. So ln e is done what? You can even check with your calculator. ln e is 1. ln 1 0. How much loge 0? Yeah, ln 0. Yeah. No. Tell me. How much ln 0?
0.
ln 0 how much? Okay, actually, of course, means it is undefined, but you should know, actually, when we say undefined, yeah, but when we say undefined, there are two options, huh? It's infinity, but infinity has two options. Negative and positive. So please tell me, do you know, when we say log0 or lm0, it is which infinity, positive or negative? Huh?
Negative.
Okay, how do you know?
That's going down.
Very good. So basically, you can verify this thing, please. So I think it's good. We are discussing the graph of natural log or LOG as well. Basically, this is a basic function graph, please. This is y is equal to logx or ln x, no problem, please. Okay. Do you know log function have asymptote? You know the asymptote?
Yes.
Which asymptote log has?
Vertical.
Vertical. Look at here.
At 0.
This is asymptote. Vertical. Y-axis. X is equal to 0. Is asymptote. And this is which asymptote? Vertical asymptote. Okay? Now you can see, as I told you, for example, if I need LM0, please, LM0, I need LM0. So basically, you are going towards 0, okay? You are going towards 0. So when you are here, so definitely, with the graph, up or down? Okay, more close to 0 from the right side. Where?
That's why we choose it.
So, when you are very close to 0, please, from right side, function going where? Oh, negative. And that's why your calculator says means error, because he has no idea about infinity. So, LM0 is, in fact, LM0 is negative infinity. Do you understand point? Very good. Okay. Right. So these are some properties which we need now to make our questions easy. Now I will share with you the derivative rule of natural log. I told you we cannot differentiate directly LOGs, please. We differentiate ln, okay? Okay, so please, the derivative of ln x, please. So we have y is equal to ln x. What is y prime? Yeah, actually, it's not only 1 over x. I think it's better if I explain in detail because it's a chain rule. Natural log, exponential base e, they have chain rule. They have chain rule, please, okay? So please, 1 over argument, multiply the derivative of the argument. Actually, this is the correct rule of natural log derivative. 1 over argument, multiply argument, derivative. How much argument here in this question? X. That's why you say ln x answer derivative is 1 by x, okay? Now, if you apply means this rule here, so my argument is x, you're right, so 1 over x and multiply the derivative of x, which is 1. That's why the derivative of ln x is how much? 1 over x. But if I change the argument, of course, it's not only 1 by x, it's different. Because this is the correct rule, by the way. Do you understand point? Okay, I give an example to understand more well, please. Okay, one more example, please. Y is equal to here. Okay, so I'll just give an example here. I need y prime, please. So what should you do?
1 over
1
Okay.
and then you will use chain rule to justify.
Okay, please. I just shared with you some properties of. It's better to first apply the property to make the question easy, please. Otherwise, it becomes 1 over sine square times sine square derivative. It takes chain rule. Oh my God, becomes too much complicated. That's why the purpose to share the properties that please use the properties first to make the question easy and then take derivative. Is that right? If you do not use the property, of course it becomes 1 over sine square times sine square derivative, right? So it's 1 over argument times argument derivative. Right now argument how much? Sine square x. So please, it's better first of all, use the property. What's the argument here? So what's the argument here? Sine x. It has power?
Yes.
So by the first property of log, we can rewrite this question like that. 2 and then what? I did not take derivative. I just applied the first property. If the argument has power, the power can come down. Agreed?
Yes.
Now you can differentiate. It's not much easier. So now y prime. Y prime. You know very well, if you have a constant which is multiplying with the function, in derivative, constant not change. Constant remains as it is. Now, now our argument is basically sine x. So by the rule of derivative which is shared here, 1 over argument multiply argument derivative. So what we get now? 1 over sine x times sine x derivative. What is that? Cosine x. What is cosine by sine? So y prime, now in simplified form, please, the y prime is basically 2 times cotangent x. What do you think? Because cosine by sine is cotangent. Sorry, yes, please, why not? Please, go ahead. Yes. Property? Okay, look at here. In this question, please tell me, what is the argument? Sine square. Or you can say sine x with power 2, right? Okay. We just learned some properties here. Look at it, the properties. This first property. If argument has power, power can come down. So because our argument is sine, it has square, it has power 2. So what we did by the first property, we bring the power down. Is clear?
Yeah, I understand the second step.
Now take derivative. What is this a rule of ln x derivative? 1 over argument multiply argument derivative. Our argument is sine. So 1 over sine times sine derivative. What is sine derivative?
Sine.
Then how much goes sine over sine?
Good.
Got that. I hope you understand. Clear? Very good. Got the idea? This is the basic idea of derivative of natural log function. Clear?
So,
Yes.
so what the differentiation?
This is differentiation. Integration after that. First we complete the differentiation, okay?
But that is inverse.
Inverse what?
There is no inverse, not only differentiation.
No. Differentiation and integration.
Integration.
Integration. Yes, we have integration. First we finish the derivative part, then we go for integration, okay?
Dr. Log and then have the same properties.
Same property. Same, please. That's why I told you. ln, log is same property, please. Don't confuse, please. Don't confuse, okay? Right. So I think it's better I take now some question from the book, please. So I download now 7.2 some questions, please, for you.
The first one, there's a
Seven point two. Okay. No. Okay. Right. This. Oh yes. Actually, in this, question, this we have put in the teams. You have some videos as well. Means if you want to check before you start the derivative, so you can watch some videos if you want some more explanation, please. Anyway, so again, the topics which are related to us, I start from that part. We can hear now we have derivative topic. That's why before it has some, warm exercises. They just check some properties. You can say we don't need that one because we're using property already. Okay, so no need to waste time on that question, please. Our main objective are only two: differentiation and integration. That's all. Other things go in that part. Okay. So, for example, I take the 16th question. Why is, again, I'm sorry, please, maybe question number not matching with your current edition because it's copied from 14 editions, okay? Anyway, number is not important. Concept is important. So let's say I go for 16, y is equal to ln(x) power 3. So, sorry. The question is that, so I don't write a number, okay? Y is equal to ln(x) power 3, find y prime, find y prime. Okay, I think it's better to use the property first so that becomes easy for us, okay? So, we can use the property? Yes. We cannot use properties because this is function power, not argument power. Agreed?
Yes.
ln(x) has power, not x has power, please. So when the argument has no power, please don't use that property. Yes, please.
If the argument had the power, we put it down.
Put it down. Inshallah, we take one question. So please, here. Here, then how differentiate? Chain rule. Oh, yes. Nx, n minus 1 times x derivative. Use chain rule. So 3.
Then x is squared.
And then x, it becomes 3 minus 2 is 2. Okay, then
What over
the
x?
derivative of the function under the power 3, which is ln x,
1 over
1 over x. I hope you understand how I differentiate this.
From outside, then it's fine.
Exactly. So, any doubt here?
How did we get the 1 over x?
Okay, because look, my brother, I have chain rule, please. Chain rule. N x n minus 1 times the derivative of x. X means base function. This base function again we write. Right now our base function is this one. So at the end you need this derivative. So what is ln(x) derivative?
1 over x.
1 over x. Understand? You can just write as a proper form if you need. So it becomes 3 ln(x) power 2 and divided by x. That's it. That's it. This is the answer of this question. I hope you understand. Is clear? Okay. Right. Actually, you can see here we have a lot of different type of questions. Please. So anyway, I took some important question quickly. Let me 26. Yes. I think go 26. ln(x), please. So go for 26 question, please. Question 26, please. Y is equal to ln(x). Find y prime, please. Find y. So this one, we have right. Can you try, please?
No.
Come on, please, means what is the problem here? The only thing you have to observe, what is the argument? Look at it, like, please. This is natural log function, right? What is the argument of ln? This is the argument. Oh, yes.
Peter, maybe you can spread them.
No. Right now you cannot do anything, please. No.
Maybe multiply.
No. This is not the product, please. ln has argument ln(x). There are arguments, not product, please. Be careful. This is the function, not numbers, please. So look at it, please. Means just follow the rule. So right now, for this is the argument of this question. Agreed?
Yes.
Okay. So look at here. Y prime, please. 1 over argument. Tell me the argument, please.
The ln
of
ln(x).
very good. Multiply the derivative of this argument, right? If you have complication, you feel it is complicated, go step by step, please. Don't go directly. Like here. So 1 over argument times argument derivative. Understand that point? So yeah, of course, chain rule, right? Okay. So this part done. So it is copy paste as it is. This one you can copy paste as it is, please. Okay, now come here. We need now, yeah, please.
It will be 1 over ln(x) times 1 over x.
Yeah, now look at here. Now we need the derivative of this function. Okay, this is which function? Cosine, sine, exponential, or natural log? Well, this is a natural log function. What is the argument here, please? The argument is basically this one. Do you understand the point?
Yes.
So as per the rule, what we do, 1 over argument multiply argument derivative. Clear? So here please, right now 1 over argument, and you just told me that argument is basically how much please? So 1 over ln x please times the derivative of ln x,
Just 1/x.
which is 1 over x. So please, this part done, please copy paste as it is. So this is 1 over this ln x, you can write first, no problem. Then this one ln with the argument ln x times, yes please. Now please complete this one. What is the ln x derivative?
1/x.
1 over x, and that's it, we got the y prime. So go step by step. Huh? Yeah, please, why not? Good question. Look at it, please. Look at here. This is the question, please. This is which function? Natural log?
Yes.
Okay, so we need its argument. What is the natural log argument? So okay, this is argument. The whole part is argument. So as per the rule of differentiation is that 1 over argument multiply the argument derivative. Understand? This part done. Now we need derivative of this part. Okay? This is which function? Natural log?
Yes.
Please identify argument.
Ln
ln x. Please repeat. 1 over argument multiply argument derivative. Of course, because it's coming again, we have to repeat again. So what is the ln x derivative? 1 over x. This part as it is. Just please. Until we get the answer, of course. Until you have derivative, please. We don't need any pending derivatives. Get the idea of how you differentiate? Okay. Anyway, I don't think so. We have here LOG's differentiation. Yeah, I think LOG's differentiation will come maybe. Here we have LOG's differentiation. Anyways, okay. At least we have started this differentiation, so you can 7 to 38 questions you can easily finish.
Sir, what about question 27?
27? No problem, 27, what's the problem here? So we have now here, the product. It is theta times sine with ln theta. Okay, 27 question. We can try, no problem, please. Question 27, please. This is y is equal to theta
Yeah.
multiplied with sine
Ln x
with ln theta, am I right?
plus cosine
Plus cosine
and ln.
ln theta.
Yeah.
Okay, now please, you should be very careful, please. This is which function?
But I think you should modify it.
Huh?
I think it was the brackets.
All?
No, sine
No,
and cosine.
only. No, yes. Theta is for all. Yes. In the question, theta is for all. Theta is for the all. You should look at the question. Huh? Okay. So do one thing. First of all, you can multiply theta with all. So it is theta sine with ln theta plus theta with cosine ln theta. Okay. I just multiply the whole thing with theta because theta is outside as a multiplier. Okay. This is sine function. If the sine function, what is that? It's an angle. Zavia, right? This is the angle. Please be careful. We have trigonometric functions, and we know very well adjacent to trigonometric function, they are called angles. So treat them as angle. Means when you differentiate, use the trigonometric rules. What is sine theta derivative? The function derivative multiply angle derivative, means the chain rule, please. Anyway, let's start. We have two functions as a product. What we use here? Product rule, UV, U prime V plus U V prime. Again, also we use here product rule. So this question is slightly lengthy, but it's fine, not difficult. So please Y prime. Use here product rule. Theta derivative.
1.
1 and sine with ln theta as it is plus theta as it is. What is sine derivative?
Cosine.
Cosine with same angle
Times the angle.
multiply angle derivative. What is the angle here?
1 over.
Ln theta. What is ln theta derivative?
1 over theta.
And the next is 1 by x. The only change is that now there's no x, it's theta.
1 over 3.
Theta is x basically. So 1 over theta. I hope you understand. Same thing repeat here. Plus, okay, again use a product rule. Theta negative is 1, so cosine with ln theta. And here is, don't mind, is minus. Why minus? Because cosine derivative is negative sign. That's why I use here negative sign. Don't confuse. Basically, is a product rule. It has addition, but I am putting here subtraction. Why? Because cosine derivative is basically minus sign. Do you understand? Yes or no, please. And the last again 1 over theta. I just use here UV product rule. I also use here product rule. In the product rule, when you calculate sine derivative, so you have to derive the angle derivative. Angle is ln theta. Is derivative how much? 1 by theta. Same here. When you derive cosine, it is minus sine please. And also it has ln theta as an angle. And ln theta derivative how? 1 by theta. Because we are using chain rule. Now we have to take some common factor because we need simplification, please. So what we can take as a common factor, please? Can we cancel anything?
They can cancel.
Sine.
We can, sorry.
Cosine then theta, 1 over theta.
Theta, cosine, and then.
It wouldn't be theta over theta.
Ah, yes, this one. You're right. I mean, this one.
Yes.
Oh, yes. Of course, you are absolutely right. Good. So now we have cosine ln theta, and it is plus basically. Oh, sine. Oh, it's also gone. It's
Yeah.
also gone. Very nice. So what is y prime at the end?
Cosine then.
2 times cosine.
Yes.
Where did you get to?
Because I have one here and I have one here. Yes or no? Simplification has marks, I'm telling you. If you just live here, you lose a marks. Simplification is required in differentiation and integration. Okay? I think it's sufficient today. So I have given you a startup. So please, you can see you have, you have this exercise. Please, you can try. Actually, there are some questions which are really, really complicated. For example, here, if you look at 34 question, this is which function? That's your log. This is argument. Argument now is very complicated. If you go in a normal way, means if you say 1 over argument multiply argument derivative, how you try this one? This is quotient and then chain and then product. Oh my God, it's too much complicated. So before derivative, what do you do here? We simplify.
Doctor, this is the theme.
Yeah. Yes, I copied from ebook. Basically, the question from ebook. Just to save time, I put in theme so that immediately you can get the question. Here, first of all, use the log properties to simplify. Then take derivative.
So how we can know if we are solving right? We want to go and practice at home. How we can know if we are...
Okay, you can check the answer from the ebook. The last page of ebook, you have answers of the odd number questions. So do one thing, when you go for practice, select the odd number question, complete it, check the answer. Because even and odd, they are same pattern. If you have done odd question correctly, even question is same like that. The very good thing in this book, the author has select the even odd like that. If you answer even question correctly, the same pattern you have odd question. So even odd have same pattern. Please select the odd number question first. Check the answer from the last page of the ebook. That's it. You can find the answer from the last page. Okay. And again, You can ask the question where I have to use property, where I have not used a property. If you think level here, if you are comfortable, the derivative of this part, and it's okay, no need to use property. But I don't think so it's easy to differentiate. Please first simplify. Because argument has quotient, argument has power, argument has product. So you can use the properties. The question become very simple. Then differentiation become very easy. Hope you understand. Okay, so please try at home, please. Then in the next class you can tell me if you have some specific question to answer. So I will answer it. Okay.
So will you take the attendance?
Yes. Now please. Okay, so we can stop recording now.